Frequency of AC supply by sonometer. The objective of the experiment is to determine the frequency of AC supply using sonometer. What is AC? AC is the alternating current, DC direct current. So in India, the frequency of AC mains is 50 Hz and voltage 230 volts. In this experiment, we are going to measure this frequency of AC mains. Resources required. Sonometer. Sonometer is a hollow wooden rectangular box. For this box, we attach a string at one end. The string is passes over the two movable bridges. These two bridges are movable bridges. A string passes over the two bridges and over pulley and weight hanger is attached at other end. Two bridges. These are the movable bridges. Two magnets, opposite polarity magnets. This is North Pole, South Pole. The magnetic field from the North Pole to South Pole. And weight hanger with a set of slotted weights. Step down transformer. It decreases the voltage from 230 volts to 60 volts, keeping the frequency constant. Keeping the frequency constant for the safety reasons. Electrical wires with crocodile clips and paper rider. The principle involved in the experiment is resonance. Resonance is a phenomenon happen in case of forced vibration. So every body has its natural frequency. When external periodic force acts on a system, if the frequency of external periodic force equal to natural frequency, then the body begins to vibrate with increased amplitude. This phenomena is known as resonance. Means you have external periodic force that acts on a system. The system also have natural frequency. When the two frequencies equal, then this body vibrates with increased amplitude. At resonance, more amount of energy will transfer. So in the experiment, the resonance is happening between external periodic force is AC supply and a body is the string under tension. So the external periodic force is the AC mains, the frequency is 50 Hz. And the frequency of a string under tension is given by nu equal to 1 by 2L root T by nu, where nu is the frequency of the string, L is the resonating length, T is the tension applied, that is acceleration due to gravity due to mass, nu is the linear density. How to produce vibrations in the string? To understand this, we have to understand flaming left hand rule. We stretch the three fingers, forefinger, central finger, and thumb. So, three fingers have to stretch in three perpendicular direction. If the forefinger points along the field direction, central finger is along the current direction, thumb will give the thrust direction, means force direction. Forefinger along the field direction, the field is the magnetic field and central finger is along the current direction. Then thumb direction will give us thrust direction. So easy way is F, F, C, C, T, T. Okay, thumb thrust. Thrust will be given by the thumb. And in case of DC, you have a constant magnitude of current. Constant magnitude of current. The field is from North Pole to South Pole. The current is along one direction, that is constant. So the force is upward direction as shown in figure. Whereas in case of AC, you have the positive cycle and negative cycle. In the positive cycle, the field is anyhow in the same direction, North Pole to South Pole. The current is along the direction and force is upward direction. Whereas in the negative cycle, the field is along the same direction, current is now opposite direction and downward direction. So in the positive cycle, in the positive cycle, force is upward direction. In the negative cycle, force is downward direction. So the force is continuously changes on the string. So this is the way we are giving the vibrations in the string. So these vibrations will be reflected by the mobile bridges and transfers in the opposite direction. Two waves traveling in the two opposite directions superpose, you have a stationary waves. Resonating length, how to do the experiment. So in the sonometer, the resonating length is the length between the two bridges. It is not the complete length of the string. The length is the length between the two mobile bridges. The experiment we do here is, this is the way. So we have the acceleration due to gravity constant, new linear density of the wire is constant, and what we do is we apply 100 grams, mass is 100 grams, and we move the bridges slowly. So by moving the bridges, we are varying the length. So we are varying the frequency. When this frequency is equal to external AC frequency, then the wire vibrates with maximum amplitude. At the time, what is the paper rider we keep on the wire, that will fall down. So we will find the resonating length related to 100. And similarly, we apply 200 grams and find the resonating length. Similarly, we will apply 100, 200, 300, 400 and 500 grams, and each case we move the bridges and we measure the related resonance lengths. For each case, we measure the what is the frequency. This frequency is nothing but the frequency of AC supply. Let me go into the doing the experiment.
Weight hanger is attached at one end of the string. Two movable bridges are placed on the sonometer box. Two opposite poles of the magnets are placed in the middle of the sonometer wire so that magnetic field is perpendicular to the length of the wire. The secondary of the step down transformer is connected to the sonometer wire using crocodile clips. Switch on the power supply, switch on the step.
Current is flowing. Now let the take the current is, this is alternating current. Let me take, this is positive cycle, negative cycle. In the positive cycle, so due to north pole, south pole, the magnetic field is like this. Magnetic field is like this. The current is flowing this. We want to know force direction. So field direction, current direction, current direction. So the force is upward. Coming to the negative cycle, is the same direction, current this direction, so force is downward. So in the positive cycle, force upward, in the direction, force downward. Let me cycle, field, current, force. Negative cycle, field, current, force.
Light paper rider is placed between the bridges. Slowly move the bridges so that at resonance the paper rider will fall down. Check the resonance condition. The magnets are exactly in the middle and the two bridges are moved nearly equal distance from the magnets. The resonating length is the length between the two bridges. One bridge at 34.9 centimeters and other bridge is at 64.9 centimeters approximately. Attach 100 grams to the weight hanger. Place the paper rider. Switch on the step down transformer. Slowly move the bridges to get the resonance condition. At resonance, the paper rider will fall down. Recheck once. The length between the two bridges is noted. Add 100 more grams so that total mass is 300 grams. Now slowly move the bridges to get the resonance. Now resonating length is measured. One is at 25.8 and other is at 74.4. Now attach 100 grams so that total mass is 400 grams. Slowly move the bridges to get the resonance. Recheck the resonance condition. Now the bridges are at 22 and 77.6 centimeters. Attach 100 grams so that total mass is 500 grams. Slowly move the bridges to get the resonance condition. Recheck the resonance. The bridges are at 18.3 and 80.8. Note down the value of linear density, acceleration due to gravity, and with increase of mass, the resonating length increases, keeping the frequency constant. The average value of the frequency is noted.
The applications are in radio communications. In radio communications, you are tuning the knob of radio means you are changing the natural frequency of the receiver. When the natural frequency of receiver matches the transmission frequency of radio station, the two frequencies match and more energy will transfer will happen and we listen to particular channel. This is the way we listen to different channels. And this kind of resonance will the phenomena will happen in televisions, mobile phones, musical instruments, lasers, and various resonances, nuclear magnetic resonance, and electron spin resonance, and various therapies, pulsed electromagnetic field therapy, and many places we have the phenomena of resonance. So in resonance, you have an external periodic force. One is the system or a body on which it is acting. When both frequencies matches, you have the more energy transfer will happen. And here we found the wave frequency of AC mains by sonometer, that is approximately equal to 49 Hz, very close to the 50 Hz. Let me give some quotation based on the frequency. Blast the vacuum of empty space hard enough at right frequency and out will pop a bunch of particles. Anonymous. Think you get the answer. Thank you.